Hi dear students, welcome to another video of 9th standard physics. In the last class, we discussed about graphical representation of motion. Mainly two types of graphical representation that related to motion. We discussed that one is distance time graph or position time graph, and another is velocity time graph. Using these two graphs, we can represent different types of motion. That is, if a body at rest, we can represent using this graph. If a body moves with uniform velocity, we can represent using these graphs. And we can represent uniform acceleration, or a body moves with a constant velocity, that is uniform velocity, we can represent using velocity time graph, and we can represent uniform accelerated motion, that is a straight line with a slope in the case of velocity time graph. Uniform accelerated motion or motion of a body with uniform acceleration, that is a straight line graph. If a body moves with a non-uniform acceleration, that not a straight line, it may be in different shape in velocity time graph. These are the main topic we discussed in the last class. Today we are going to discuss another topic, that is equations of motion. We are going to discuss that equations of motion. What is equations of motion? Equations of motion. Mainly, three types of equations of motion is there. There are three equations of motion. Using this motion, we can find out different mathematical calculations. That means, imagine if a body moves with a uniform acceleration. If a body moves with a uniform acceleration, that means the body starts with a velocity u, that is known as initial velocity. That is known as initial velocity. If the body moves with the initial velocity u, after some time, that is t, after some time, the time interval t is the time, this body moves certain distance or displacement in a straight line. Then if a body moves certain distance or displacement, we can represent it by letter S, that is distance. And if we apply a force, or if we produce an acceleration for this body, that means a change of velocity happens in the motion of this body, then what happen? Velocity changes from initial velocity changes to another velocity, that can be represented by letter V, that is known as final velocity. V is final velocity. Okay. Then we produce an acceleration. If the velocity changes, then what happen? There will be an acceleration. Then acceleration can be represented by letter A, small letter A, that is A is acceleration. A is represented as acceleration. These are the terms related to equations of motion. We want to identify the terms, that is u is initial velocity, t is time, and s is distance traveled by this body, v is the final velocity, and a is the acceleration produced for this body. Using these terms, we can express three equations of motion. Three equations of motion. In these equations of motion, we can relate velocity with the time, and distance with the time, and distance with the velocity also. That is a relation is That is the relation shows in these equations. What are the equations of motion? What are the equations of motion? First, I want to write equations of motion here. Listen here. There are three equations of motion. The first equation, that is V, final velocity V. V is equal to u plus at. This is the first equation of motion. V is equal to u plus at. The second equation of motion is S, that is distance or displacement. S is equal to ut plus half at square. This is the second equation of motion. S is equal to ut plus half at square. Whereas then the third equations of motion is, that is 2as is equal to v square minus u square. These are the three equations of motion. Then what is the term used here? V is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. And here s is the distance traveled by this body, u is the initial velocity, t is time, a is the acceleration. Then here a is the acceleration, s is the distance traveled by body, v is the final velocity, u is the initial velocity. Then these three equations can be represented like this. The first equation is known as relation between velocity times. Okay, the first equation shows the relation between velocity and time. The second equation shows the relation between distance and time. The third equation shows the relation between distance and velocity. Okay, these are the three equations of motion. Do you understand? These three equations is applicable. These three equations are applicable for uniformly accelerated motion. These three equations are applicable for only uniformly accelerated motion. And these three equations can be derived from graphical method. We can be derive these three equations from graphical method. Next, we are going to see how can we derive these three equations from graphs. Okay, let's do that. First, we are going to derive this equation, first equation of motion, that is v is equal to u plus at. That is equation for velocity time relation. We are going to derive the equation for velocity time relation. The velocity time relation, that is v is equal to u plus at. We are going to derive this equation from this graph. Then which type of graph is this? This graph represents uniform accelerated motion of a body, because here the graph is represented as a straight line graph with a slope. We know that in the case of velocity time graph, if the graph is a straight line with a slope, means it shows a body moves with a uniform acceleration. We already said that is these three equations of motion is applicable for only uniformly accelerated motion. That's why this is also graph for uniformly accelerated motion of a body. And here we can note that the body moves with the initial velocity that is not equal to 0. Here initially we can represent it as u. Here u is not equal to 0. That means if the graph starting from origin means the value initial velocity may be 0. But here graph does not start from the origin. Here graph is started from the point A and finally it reaches B. That means here initial velocity has a value. What is the value of initial velocity? That is initial value of initial velocity is OA. The length of OA is the value of initial velocity. that is, it can be represented. OA is represented by letter U. U is the initial velocity, that is not equal to 0 here. Then again, after some time, time interval t, then what is the time interval here? Here the velocity changes to another value. The final velocity, that is v, can be represented by letter b, by this bc. Okay, bc is the final velocity, that is, this length is bc. Here bc and oe's are equal. That means this oe or bc is the length of bc is the value of final velocity. That is, this is the final velocity. BC is the final velocity, that is V. Okay, then what is the time interval between this velocity changes? Here velocity changes to another value. Here initial velocity is U. After some time velocity changes to this value. Then what is the time interval between this change of velocity? That is OC. OC is the time interval between this change of velocity, that can be represented by letter T. Okay, and here OC is T. Okay, what you understood from this? That is OA, that is initial velocity, that is U, and here BC is the final velocity, the length of BC is the final velocity, that is V, and OC is the time interval to change of velocity, that is letter T. Okay, then listen here. Then we can represent from this line BC. Then what is BC? BC can be written like this. BC is equal to, what is BC? BD plus DC. BC is equal to BD plus BC. Okay, that is BC is equal to BD plus DC. That is, I have written here. Then we can represent BD. What is BD here? BD is equal to, if it changes this BC into this side, sorry, DC here, DC, then if we BD is equal to BC minus DC, BC minus DC. Then here BD is equal to, what is BC? BC means we represented BC is V. Okay, BC is equal to V, which V final velocity, that is BC. Then what is DC here? This is DC. But from this graph we can understood that DC is equal to AO because it is parallel. Okay, and DC is equal to AO. That means this DC is also, that is equal to U, and AO and DC's are equal. That's why DC is equal to U. Then we can be represented letter U. That means what is, from this we obtain that BD is equal to V minus U, that is change of velocity. The BD is the change of velocity. This length BD is the change of velocity, that is V minus U. BD is the change of velocity, that is V minus U. Okay, then we know that what is the equation of acceleration. What is the equation of acceleration? We know that acceleration A is equal to change of velocity by time, isn't it? Acceleration is the rate of change of velocity. We know that, we already learned that. Then we can represent A is equal to change of velocity by time. Then what is change of velocity? And here change of velocity is BD. That means A is equal to BD. Then what is the time interval here? OC. That is change of velocity here. BD, change of velocity V minus U, that is BD, and that can be represented change of velocity BD divided by time interval, that is OC. Then here we can change OC into AD, because here OC and ADs are equal. This length and the lengths are parallel and equal. Okay. And this is our AD. Then we can be changed like this BD divided by AD. Then what is BD divided by AD? And A is equal to, listen here, BD, what is BD? V minus U. Then we can represent like V minus U. Then what is AD? AD is the time interval OC. Okay, OC is time interval. That means AD is also T, time interval, that is T. A is equal to V minus U by T. This is equation of acceleration. We already learned that. If you rearrange this equation, what you obtain? That is, if it changes T to this another side, left hand side of this equation, if it goes this T, then what we get? That is AT is equal to V minus U. Then if we rearrange this equation, what we obtain? If minus U changes to this side, that means plus U. That is V is equal to here U plus AT. That is the first equation of motion. V is equal to U plus AT. This is the equation for velocity time relation that is derived from this graph. We derived the equation for velocity time relation V is equal to U plus AT from this graph. Okay, do you understand? Next we are going to derive second equation of motion from the graph, that is equation for position time relation. Equation for position time relation. Equation for position time relation. Then what is the equation of position time relation? That is S is equal to UT plus half AT square. That is the second equation of motion. We can derive this equation from this graph. Okay, then in the last class we discussed from velocity time graph we can find out the displacement travel or distance traveled by a body in a specific time interval. How can we find out from velocity time graph the distance traveled by this body between this time interval OC? How can we find out? Can you say? Can you say the distance traveled by this body between this time interval OC? How can we find? In the last class we discussed that we want to calculate the area of geometrical shape that falls under the graph, that is equal to the total distance traveled by this body. Okay, that means if we find out the area of the shape, then this value of area is numerically equal to the displacement or distance traveled by this body. That is the method to find out distance or displacement traveled by this body from velocity time graph. That means we want to find out this area of this shape. Then what is the shape? Here OABC. If we find out the area of OABC, then we can area of OABC, that is equal to area of OABC, that is equal to displacement or distance traveled by this body between this time interval, that is T. Then how can we find out the area of OABC? Here area of OABC, we know that this shape is a shape of a trapezium. This is a trapezium shape. Then we can find out the total area of trapezium by adding the area of rectangle AOCD and the triangle ADB. If we add these two area, we get area of trapezium OABC. What is that? That is area that is equal to area of triangle. Sorry, area of triangle ABD. Area of rectangle. Area of rectangle OADC plus area of triangle ADB. That is area of trapezium OABC. Then how can we find out area of rectangle OADC? That is, we know that is OC, length into breadth. That is OC into DC. That is OC into DC. Plus then area of triangle ADC can be find out half BH means here half BD into AD. Okay. Then here we know that OC is equal to AD. OC is equal to AD. Here OC is equal to AD. Then we can change this to AD into OC. No problem. Okay. Then what about DC? DC is equal to OA, that is initial velocity U. Okay. Then if we substitute this value with these terms, that is OC is equal to T into DC. What is DC? That is initial velocity U. That is U plus half. What is BD here? BD is V minus U, change of velocity. From the first equation we know that V minus U, that is equal to AT. That is BD is equal to AT. From the first equation of motion, V is equal to U plus AT. If we rearrange the equation, V minus U is equal to AT, then V minus U is equal to AT means V minus U is equal to BD, then BD is equal to AT. Then we know that BD is equal to V minus U, that is equal to AT. That is, if you substitute the value BD, that is AT, then half AT into OC. What is OC? OC is T, then T. Then area, we get that area that is equal to displacement. The displacement can be represented by letter S. Okay, then S is equal to, that is area is equal to S, displacement. Then we can write S is equal to UT plus half A T into T square. That is S is equal to UT plus half AT square. That is the second equation of motion. That is equation for position time relation. That is S is distance and U is initial velocity, T is the time. This equation shows the relation between position time relation of motion. That is S is equal to UT plus half AT square. That's also derived from this graph. Do you understand? Next we are going to derive the third equation of motion, that is 2A is equal to V square minus U square. This is the equation for position velocity relation. This is the equation for position velocity relation, that is S is the position and V is the velocity. Then 2AS is equal to V square minus U square. Then how can we derive this from this graph? Here, listen here. If a body moves with uniform acceleration a, then initial velocity is u and final velocity is v, we can find out the displacement of this body between this time interval OC by finding the area of trapezium OABC. By finding the area of trapezium, we can find out the displacement. That area is numerically equal to the displacement traveled by this body. Then how can we written as, that is the area that equal to area of trapezium OABC, that is numerically equal to displacement. Okay, that is displacement. Then displacement, yes. Then what is area? Yes is equal to area. What is area of trapezium? What is equation of area of trapezium? We already learned that how can we find out the area of trapezium A is, area means we know that is half H A plus B is the equation. Then what is A here? In the case of a trapezium, A is AO. Imagine it is a trapezium. If it is a trapezium and A is this side is the A and this side is the B, and the parallel side, distance between the parallel side, that is H, and this is the trapezium. This is the shape of this trapezium shape. Can we compare with this shape, with this graph? How can we get this value A? And A is equal to here AO, and B is equal to here BC, and H is OC. Okay, then from this equation we can write S is equal to half. What is H here? H means OC. Half OC. Half OC. S is equal to half OC. Then H into A plus B means A means AO. AO plus BC. AO plus BC. This is the equation to find out area of trapezium. That area is equal to displacement traveled by this body, that is S. S is equal to half OC AO plus BC. Then we are going to substitute the value of OC, AO, BC from this graph. Then we get S is equal to half. What is OC? That is time interval T. Then T into. Then what is AO? That is initial velocity. AO is initial velocity U plus. What is BC here? BC is final velocity V. That is S is equal to half T U plus V. From first equation of motion, we know that V is equal to U plus AT. If we rearrange this equation to obtain an equation for time, then what is the equation for time? That is AT is equal to, from this equation AT is equal to V minus U. Then T is equal to V minus U divided by A. Okay, if we substitute the value of T, V minus U by A, in this equation, in the position of T, we want to substitute this value V minus U by A. Then what we get? S is equal to half V minus U by A. In the position of T, we substitute this V minus U by A into U plus V. Then we obtain, that is, the changes like this. Okay, this 2A here and V minus U. Then we can return as S is equal to, what is V minus U into V plus U? V minus U into V plus U. we know from the mathematics, that is v square minus u square. V minus u into v plus u is v square minus u square divided by 2a. Then if we rearrange this equation, we obtain that 2a s is equal to v square minus u square. This is the third equation of motion, that is equation for position velocity relation. That is the third equation of motion. 2as is equal to v square minus u square. Then we we derived this equation. Then how can we conclude that what are the equations of motion? What are the equations of motion derived from the graph? We derived from this graph three equations of motion. One is first equation of motion, that is v is equal to u plus at. This is the first equation of motion. The second equation, this is the relation between, what is the relation between, this equation represents the relation between equation of motion, this equation represents the relation between velocity time relation, and second equation, that is s is equal to ut plus half at square. That is second equation of motion. It is represent the equation for position time relation. And third equation of motion, that is 2as is equal to v square minus u square. The third equation of motion. This motion represent the relation between position and velocity. These are the three equations of motion. First equation is equal to v is equal to u plus at. Second equation is equal to s is equal to ut plus half at square. And third equation is 2as is equal to v square minus u square. Okay, let's do some problems regarding with these equations. Okay, what is the first problem? The first problem, that is a train starting from rest attain a velocity of 72 km per hour. 72 km per hour. Okay, attain a velocity of 72 km per hour in 5 minutes. In 5 minutes. Then, assuming that the acceleration is uniform, find the acceleration. First question, find the acceleration. Second question, the distance traveled by the train for attaining this velocity. That is the question. Then a train starting from rest attain a velocity of 72 km per hour means, a train starting from rest means initial velocity is 0. That is u is equal to 0. Okay, initial is 0. Then it attain a velocity of 72 km per hour, that is final velocity is v is equal to 72 km per hour. Then the time to attain this velocity is 5 minutes, that is t is equal to 5 minutes. These are the values given in this question. We want to find out, first question we want to find out the acceleration. Second question, we want to find out distance traveled by this train at this to attain this velocity. How can we find out? Do you know how can we find out? Yes, listen here. We want to change this value kilometer per hour into SI unit, that is meter per second first. And here time is in minutes, then we want to change this into second. And how can we change this? V is equal to 72 kilometer per hour. Then if we want to change kilometer per hour into meter per second means, we want to multiply with this value with 5 by 18. That is 72 into 5 by 18. Then what is 72 divided by 5 by 18 means, in 18 up to 72, 18, that is 4 into 18 is 72, that is 4. If you divide 72 divided by 18, we get 4. Then 4 into 5, that is 20 meter per second. That is the value of 72 kilometer per second. That is equal to 20 meter per second. We want changes to SI unit. And again time, that is t is equal to 5 minutes here. Then we want to change to second, means 5 into 60, that is 300 second. Okay, that is 300 second. Then we want to find out the acceleration. That is the question. Then what is the equation of acceleration? A is equal to v minus u by t. That is the equation for acceleration. Change of velocity divided by time. This is the first equation of motion. V is equal to u plus at. If you rearrange the first equation, we get this equation. Okay. Then A is equal to v minus u by ut. Then v, what is v? 20. What is u? 0. Divided by t is 300 second. Then what we obtain? 20 divided by 300. That means if we cut this 0, we obtain 1 by 15 meter per second square, and is acceleration. This is acceleration. A is equal to 1 by 15 meter per second square. The next we want to find out the distance traveled by this train to attain this velocity 20 meter per second. That is second question. Then how can we find out the displacement? By, in this question there is no time is given. Okay, which equation that represent the relation between position and velocity? That is the third equation of motion, that is 2a is equal to v square minus u square. There is no time in that equation. Okay, if any question that does not given time, then we can use the third equation of motion, that is 2as is equal to v square minus u square. We want to find out distance, means we want to find out s. And a is, we know that a is the value of a is 1 by 15. What is the value of v? That is 20 meter per second. Then u is 0. We substitute this value, 2 into a is 1 by 15 into s. V square means 20 square minus 0 square. Then what is the value here? 2 by 15 into s. What is 20 square? 400. Then what is s? Then 400 into, if you multiply with the reciprocal, we get 15 by 2. Then what is the value? That is 200 into 15. 200 into 15. That is 2 into 15 means 30. Then 20 given. That is 3000 meter. That is the distance traveled by this train. 3000 meter is the distance traveled by this train to attain this velocity 72 kilometer per hour, that is 20 meter per second. Okay, do you understand? This 300 meter can be converted into kilometer, means that is 3 kilometer. Okay, sorry, 3000 meter is converted into, that is in kilometer, 3 kilometer. Okay, this is the answer. That is acceleration is 1 by 50 meter per second square. The distance travelled is 3 kilometer. Do you understand? Second question, that is a car accelerated uniformly from 18 kilometer per hour to 36 kilometer per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. Then what are the values given in the question? That is, one is the car accelerated uniformly from 18 kilometer per hour to 36 kilometer per hour, means here initial velocity is given, that is u is given, u is 18 kilometer per hour. Okay, and this changes to 36 kilometer per hour, that is final velocity. V is 36 kilometer per hour. Okay. And time is given, the time taken to change of this velocity is 5 seconds. T is 5 seconds. First we want to find out the acceleration of this car. Acceleration of this car. How can we find out acceleration? Before that, we want to change this kilometer per hour into meter per second. That is the SI unit of velocity. How can we change? That means we already learned that 18 kilometer per hour changes meter per second means multiply with 5 by 18. Then we can convert it into meter per second. That is equal to 18 and 18 cancel. Then 5 meter per second or 5 meter per second. And this is the value of u. And again value of v can be find out, that is 36 into 5 by 18. 5 by 18. That means 36 divided by 2. That is 2 into 5. That is 10. 10 meter per second. That is the value of v. Okay. If you find out acceleration, that is a is equal to equation a is equal to v minus u by t. Then v is equal to, what is v? 10. 10 meter per second minus 5 meter per second divided by t is 5 seconds. Then we obtain 10 minus 5 is 5. That is divided by 5. That is 5 by 5. That is 1 meter per second square. 1 meter per second square. This is the acceleration of this car. Okay, this is the acceleration of this car. Second question. This is the first question. Second question. Find out the distance traveled by this car at this time. At this time, what is the distance traveled? Here time is given. Then we want to find out distance. Then what is the relation? Which equation can be used here? The position time relation. We want to find out position from the time. That is position time relation can be used. That is a second equation can be used. Is equal to ut plus half at square. This is second equation of motion. We want to find out distance. Yes. Then substitute this value u. What is u? U is 5 meter per second. That is 5 into t is time 5 plus half. What is a? Acceleration is already find out from first problem. That is 1 into t square. T is 5. Then 5 square. Okay. Then 5 into 5 we know that's 25 plus half 5 square, that is 25. 5 square means 25. We know that 25 plus, what is a half of 25? That is 12.5. Half 25 means 12.5. Then if we add this, what we get? That is 37.5 meter. This is the distance travelled by this car at this time 5 seconds. Okay, 37.5 meter is the distance travelled by this car at this time. Okay, the third question, that is the brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If the car takes 2 seconds to stop after application of brakes, calculate the distance travels during this time. This is the question. The brakes applies to a car produce an acceleration of 6 meter per second square. That is, what are the value given? That is acceleration, that is 6 meter per second square. That means here in this question brake is applied. That means here the force is applied in the opposite direction of the motion by the brake. That is, here acceleration is retardation. Retardation means the velocity decreases. Okay, when we brake applies, velocity decreases. That means here acceleration produces in the opposite direction of motion. That's why we want to take the minus value for acceleration, that is minus 6 meter per second square. Because here acceleration is produces in the opposite direction of the motion. Force is applied in the opposite direction of the motion. That's why acceleration is taken as minus value. A is equal to minus 6 meter per second square. Then another value is given in the question. Time is given. Okay. Time, what is time? T is 2 seconds. And after some time this body comes to rest. That means the final velocity is 0. Final velocity is 0. V is equal to 0. Why? After some time, after the application of brake, the car changes to rest, means the final velocity becomes 0. Initially not 0 because the car moves with a velocity. After application of brake, it is velocity changes to 0 after some time, after 2 seconds. Okay, that is V is equal to 0. First we want to, question is, what is the distance traveled by this car during this time? For that we want to find out what is the initial velocity. U, we don't know. We don't know what is value of U. How can we find out value of U? Which equation can be used? Yes, from the first equation of motion. Velocity time relation, that is V is equal to U plus AT. We want to find out U, that is U is equal to V minus AT. If AT changes in the sign, it changes to minus. Then if you substitute the value, that is V is equal to 0. What is A? A is equal to minus 6 into T, that is 2 seconds. Then minus into minus plus, that is 12 meter per second. That is our initial velocity. 12 meter per second is the initial velocity. We want to find out the distance traveled by this car at this time after the application of brake. Then what is the equation used for to find out that? That is S is equal to ut plus half AT square. Then what is U? U is 12 meter per second. 12 into 2 plus half. Here acceleration is minus 6 into T square is 2 square. Then 12 into 2, that is 24 plus half it, here minus 6 into 4. 6 into 4. Then here 4 by 2 is 2. Then 24 minus 6 into 2, 12. Then we get 12 meter. The value given. After the application of brake, car traveled 12 meter. Car traveled 12 meter after the application of brake. This is the solution of this problem. Do you understand? Okay, in this class what we discussed? Yes, mainly discussed 3 equations of motion and derivation of these 3 equations of motion from the graph. Okay, and some problem regarding these 3 equations of motion. Then what are the 3 equations of motion? First equation of motion, V is equal to U plus AT. This equation shows the relation between velocity time relation, and second equation is a equation for position time relation, that is S is equal to ut plus half AT square. That is the second equation of motion. Third equation of motion, that equation shows the relation between position velocity relation, that is U2as is equal to V square minus U square. Okay, these are the topic we are discussed in today. Let's do the follow-up activity. Don't forget to do the follow-up activity given. Thank you for watching my video.